Okay, so my questions were on Trigonometry 2, Exercise 3A, questions 1B, D, and F. And here you have x equaling a cosecant theta and y equals b cotangent theta and z equals c sec theta. And the first question, b, was b squared plus y squared. And we know that y squared here is b cotangent theta. So I changed that right here. And then cotangent theta can be written as cos theta over sine theta. And then I left the squared right there. And that is then I opened the brackets here, and next I changed I factorized it. So from that, got rid of one of the b squared with factorizing, and this one I wanted to add the 1, so I had to add a denominator, and I did that right here by changing the 1 to a sine squared theta over sine squared theta, and that came out like this. And then the final one that you get out of that is b squared cosecant squared theta, because you have the sine squared theta plus cos squared theta over sine squared theta equaling cosecant squared theta. And then for my next question, which was D, x over x squared minus a squared. And we know that we know that x is a cosecant theta. So in the first transformation right here, I changed that. I changed the x, and at the bottom here I changed it to a cosecant theta squared. And here then I opened the brackets from that. So we came out with a squared cosecant squared theta. And then I factorized the denominator and left the top the same, like this. So then I got rid of one of the a squareds. And moving on, what I did is I simplified what was inside the brackets. So I changed it to 1 over sine squared theta. And then on the top here, I changed the a cosecant theta to a over sine theta. And here I continued with the denominator by adding the minus 1 to the fraction. So I did minus sine squared theta over sine squared theta. And that gives me this, which I then simplified to a squared cos squared theta over sine squared theta, because 1 minus sine squared theta is cos squared theta, and then I added the a squared to the top of the fraction. And then you would basically just flip the bottom fraction and get a over sine theta times sine squared theta over cos squared theta, and that was really easy to cancel out. So I was left with sine theta over a cos squared theta, which then turns into 1 over a tan theta over cos theta, because I took the a out of this fraction, and then sine theta over cos theta would give me 1 tan theta, and then I'd have 1 cos theta left. So it was like this. Where is it? Here it is. And this can also be written as 1 over a tan theta sec theta, but it can also be left like this. And then for my final question, I have square root of z squared minus c squared over z, and we know that z is c sec theta. And so I just changed that in the very first time. I changed the z's, both of them, the squared one and the simple one, on the denominator. And then I opened the bracket in the top one. So I got c squared sec squared theta, and left everything else the same. Then I was able to factorize, so got rid of one of the c squared. And then I was able to change the sec squared theta to 1 over cos squared theta, which is very useful. And moving on, I changed I added the minus 1, I added the minus 1 to the fraction by having this minus 1 just go into the fraction as cos squared theta over cos squared theta. So it was minus cos squared theta over minus cos squared theta. No, that's wrong. It was minus cos squared theta over minus cos squared theta, yes. And then I added that in here and canceled it out. Not canceled it out, just simplified it, because 1 minus cos squared theta is sine squared theta. And this I then square rooted. So it came out with this, and put the c at the top of this fraction. And then again flipped the fraction and was able to cancel these out. That would have given me c sine theta over c, which is equal to sine theta. And that is all.